In this problem, we have 4,800 square inches of material, cardboard, with which to make a box that has a square base and an open top. So let's try to draw a box here and put some labels on it. So here's our box, and this is the top here, let's say, and that's open. So this is the base, and the base is square, so the base will be x inches by x inches, and the height of the box will be y inches. So we've drawn a little diagram and labeled with some variables. Now we'll start answering the question. The volume we're trying to maximize. The volume is equal to the length, which is x, times the width, which is also x, times the height, which is y. So the volume is x squared times y. And we would like to maximize this. And we have a problem in that the volume is defined in terms of two variables, and we need to change that so that the volume is written in terms of just a single variable. And the reason that we can do that is because of our material constraint. The total amount of material that's used to make this box is equal to x squared square inches for the base, plus each side is going to be x inches by y inches. The front here is x inches by y inches. The back is x inches by y inches, and so are the sides. So there's four sides. We have 4xy. The front, the back, and the two sides. That's 4xy. And the total amount of material, if we're trying to maximize the volume, we should use all of the material. So that will equal 4,800. And we can solve this somewhat complicated equation here for y. So let's do that. 4xy is equal to 4,800 minus x squared. And then if we divide by 4x, y is equal to 4,800 minus x squared, that quantity, divided by 4x. And we can take this back into our volume equation now, so that our volume could be written, instead of x squared times y, our volume is x squared times this fraction, 4,800 minus x squared divided by 4x. And this is a little bit more complicated on one hand than the original equation x squared y here, but it's nicer in the sense that there's only one variable, just x, on the right hand side. And let's just make this look nice. First of all, one of the x on the bottom can cancel with one of the x's on the top, so this x squared will cancel out this x here. And then if we distribute the x and simultaneously divide by 4, we'll get the following. 4,800 divided by 4 is 1,200 times that x, minus 1 divided by 4 is 1/4, and then x times x squared is x cubed. So our volume function is the cubic polynomial, 1,200x minus 1/4 x cubed. And when x is 0, the volume is 0, so this cubic polynomial goes through the origin, and it has a shape that looks something like this. If we were to use our graphing calculator to have a look at it, that's supposed to go through the origin there, I missed. And this is our v-axis for the volume, and this is x. So we see that, first of all, we're not interested at all in when x is negative, because that doesn't make sense in our problem. So just looking at this part of the graph where x is positive, we see that our function has a maximum right around here where the derivative is 0. So v prime will equal 0. And that's how we solve the problem. We calculate V prime. V prime is, here's our V. V prime is 1200 minus, when we bring down the 3 times 1/4 makes 3/4, x squared. And we set that equal to 0 because the solution occurs when the derivative is 0. We're looking for the maximum. So 1200 minus 3/4 x squared is 0. That means 3/4 x squared is equal to 1200. Multiply by 4, divide by 3. X squared, if we divide by 3 first, it's 400 times 4. We should get x squared equals 1600. And then x would be plus or minus the square root of 1600 is 40. So x equals plus or minus 40. The plus 40 is clearly, that's 40 inches, is clearly our answer. The minus 40 would correspond to this other point on the graph that we don't care about. So our answer is x, to maximize the volume, x should be 40 inches. And then to find the rest of the solution, the y would be 4800 minus the x squared. So 4800 minus 40 squared is 1600. And then we would have to divide that by 4 times 40, which is 160. So we're running out of room here, but let's just put that right here. The y equals 3200 divided by 160. And 32 divided by 16 is 2. And one of the zeros will cancel, so we'll get 20 inches. So the y should be 20 inches. And the volume, the maximum volume would be x squared is 40 squared times 20. And that would be 32 with 3 zeros, so 32,000. And it's inches times inches times inches, so that's cubic inches. 32,000 cubic inches is the maximum volume of our box. It happens when x is 40 inches and y turns out to be, I'm plugging in here, the number 40, y turns out to be 20 inches.